Alright, we're going to work through some of these alpha, beta, and gamma decay problems. The interesting thing about this worksheet is that whatever answer you start with on the previous problem will be your answer over here, and that's a way to check your work. So, here we go. We'll start with uranium-235. Atomic symbol for uranium is U. The atomic number for uranium is 92. And the atomic mass for this particular uranium is 235. Now, keep in mind, you're not going to use the uranium. So, you won't be using the uranium that you see on the periodic table. That's the average of all uranium that we know of. You're going to be using a particular isotope. In this case, 235. So now it says it undergoes alpha decay. From your reading, once it says emit, you know that that is your reaction arrow. So everything else will be on the right-hand side of that reaction arrow. Once it says emits, you know that. An alpha particle, from your reading, you know, is a helium nucleus. So it weighs 4, it's got 2 protons, it's He. The way we solve these problems, it would make a lot of sense for you to write somewhere what an alpha particle, beta particle, and gamma particle look like, so you can always reference them. So I'm going to do that now. Alpha is a helium nucleus. Beta is a high-speed electron, so it has no mass but a -1 charge. And gamma is a photon of light, so it has no charge, no mass, and you write the Greek symbol gamma. Okay, so these problems at their root are really just addition and subtraction problems. This side of the equation, this being our equal sign, always has to add to the same as this side. So whatever the mass is over here, our mass on this side has to add to the same thing. So if this mass is 235 and we have 4 there, we need to figure out what to add to 4 to get 235. When we think about what we're going to add to 4 to get 235, come up with the answer 231. Same thing applies for the number of protons. On this side we have 92 protons. On this side we have 2 protons. 2 plus what number is 92? We should get an answer of 90. Then you look to your periodic table and decide which element has 90 protons. As I look at the periodic table, it looks like it should be thorium. Now, thorium, 231 is your final answer. And, wouldn't you know it, the next problem starts with thorium 231. So all of these problems will go in order. Whatever your answer was from the previous problem will be what you start with in the next problem. So immediately we can start this next problem off with our thorium 231. Thorium is element number 90. This tells us that thorium 231 emits. Once you see emits or undergoes a certain amount of decay, it's a reaction arrow. Thorium 231 emits a beta and a gamma. So we'll draw our beta, which is just a high-speed electron, and a gamma. Gamma just alerts us to the fact that there's radiation, but doesn't change the mass or charge, so really has no bearing on our actual equation. So now as I look at this, I say, well, this is 90, this is -1, so -1 combined with what number is 90? Should be 91. Here we have 231, here we have 0, here we have 0, so 231 should remain. 231. I look at the periodic table. Element number 91 is Pa, protactinium. So that's our final answer. And wouldn't you know it, protactinium 231 starts our next problem. So, as you go through and solve these, the way to check your work is to see that whatever you finish with here should start you off on the next problem. Now, I'm going to do the last one because it looks a little bit different. So down here we have polonium 215. So I'm going to start with polonium 215. And polonium on the periodic table is element 84. 84. So it says it emits an alpha and a gamma, so we'll draw our alpha particle, which is really just a helium nucleus. And our gamma ray, no mass, no charge, doesn't really have any bearing on our equation, and our answer. 215 is how much it weighs on the left side, so we need our whole right side to add up to 215. 4 plus 211 is 215. Our number of protons is 84. The number of protons on the right-hand side has to add to 84. 2 plus 82 is 84. Look to my periodic table and see that element 82 is lead. So this says the product from above emits a beta. The same pattern emerges, but now it's not giving you the check. So you got lead 211, so lead 211 is what will start your next problem. Alright, that's it for alpha and beta decay. Comment if you have any questions.